Welcome. I am Professor Jain Mandal, Department of Civil Engineering, Indian Institute of Technology, Bombay. I will now discuss the Atterberg limit state, and the main aim and objective of this test to determine the range of moisture content which exhibits certain consistency of a given soil sample. In 1911, the Swedish scientist Atterberg reported an extensive study on the plasticity of the soil sample. In the progressive transition from liquid state to solid state, the soil undergoes dramatic change in consistency. All limits are expressed as water content. Now, what is the liquid limit? It is the boundary between the liquid and the plastic state. So, soil has a negligible shear strength. Now, what is plastic limit? It is the moisture content at which a thread of soil just begins to crack and crumble when rolled to a diameter of about 3 millimeter. And what is shrinkage limit? The maximum water content expressed as percentage of oven die weight at which any further reduction in water content will not cause a decrease in volume of the soil mass. So, we know that what is the liquid limit and the plastic limit and the shrinkage limit. Here you can see that water content in percentage, and this is the volume of the soil. So, this part is the volume and this is the water content, and this is in the dense, this is solid state, and when the water content in between the solid and the plastic state, then we say the semi solid state. When the water content between the plastic and the liquid limit, we say it is the plastic state. So, this chart shows that consistency of the limit start, and when it is behind that liquid limit, then you call as a liquid state. Then there are certain terms which you call the plasticity index, and the index provides a measure of the amount of moisture content that is to be added to change the soil from plastic state to liquid state. That means plasticity index is equal to liquid limit minus plastic limit. So, if you can determine the liquid limit, if you can determine the plastic limit, so you can determine the plasticity index. Now, there is another term which you call the liquidity index, and that designated of IL. This index can provide a clue as to the condition of in situ soil. This index can be defined as I is equal to natural moisture content minus the plastic limit divided by liquid limit minus plastic limit. And another term which is called the flow index. The index is the slope of the flow curve. So, these are the terms are very important. Now, for the determination of the Atterberg limit, we require some apparatus and accessory. So, we require liquid limit device and the grooving tool. You require shrinkage limit set consisting of the petri dishes, glass plate with the front, mercury, evaporating dishes and measuring cylinder. You recall large glass plate of for plastic limit state, you require distilled water, you require oven, you require balance of 0.1 gram accuracy and the desiccator, moisture can, spatula and cotton waste, duster and grease or oil, etc. These are the some that accessory or apparatus are necessary for the determination of the Atterberg limit. First of all, that we want to determine that what will be the liquid limit of the soil. To calculate the liquid limit of the soil, we require the liquid limit apparatus. So, this is the liquid limit apparatus, and you can see here the brushed steel or the brushed plate, and this is the complete cup mechanism brush, and this it can be rotate and you can feed the soil into this cup and then you can rotate it. So, this I will show you detail about this, how you can perform the test, and here it is more detail is given. This is the cup and this is the soil. Okay, at a particular moisture content you can paste the soil and then you can use this. I am showing also here. This is the height of the gauge, this is the grooving tool. This grooving tool we use to cut the soil, and this is all this dimension of the grooving tool and height of the gauge is given here. So, using this grooving tool, then you can cut the soil, okay. And here this way you can process for the liquid limit, and the procedure is that you take about 200 gram of the soil which is passing through 425 micron in a porcelain dish and mix it thoroughly with the distilled water using the spatula until the soil mass become thick homogeneous paste. Next, you adjust the liquid limit device with the aid of the gauge on the grooving tool to obtain the of the cup equal to 1 centimeter equal to above the base. Then turn the handle at practice to obtain a speed of 2 blow per second. Now, turn the handle at the rate of 2 revolution per second and count the blow necessary to close the groove in the soil for a distance of about 12.7 millimeter. Now, take the sample of the soil paste from near the closed groove and keep in the moisture can for determining the moisture content of the soil. Next, you have to repeat the above procedure 3 or 4 times by changing the amount of the distilled water added to the soil, such that the number of blow required to close to the groove is between the 10 to 40. So, you have to blow in such a way that this number of blow should be lie between the 10 and the 40, and then you can draw a flow curve and find the liquid limit and the flow index of the soil sample. Now, here that procedure for the liquid limit determination is shown. So, initially it is here, initially place the soil paste in the cup, okay, and then is divide this paste by drawing the grooving tool. This is the grooving tool. You are just pushing like this, you are pushing like this, and this enter. They divide this paste by drawing this groove foot. Okay. Then you can turn the handle at the rate of 2 revolution per second and count the blow necessary to close to the groove when this will come in contact. Then you take the soil sample from this zone and then place it into the can. Then you can determine what will be the moisture content, okay, of the soil. Like that, you can then again you can change the moisture content, and then again you place this soil sample into this cup, and then again you divide this paste by drawing the grooving tool, and then at the end you are to turn the handle at a rate of 2 revolution per second and count the blow repeatedly to close this groove. So, that way you take the different moisture content and then you determine what will be the moisture content of the soil. Now, here you have been given specimen calculation for the liquid limit, how to calculate this. So, you have taken different can, that is a number 7, 74, 16, 131. Then you take the weight of the wet soil and the can and you calculate what will be the weight of the wet and the soil. Then after drying the soil, you can take the weight, dry weight of the soil and the can in gram. You can see 47.82, 45.871, 45.810, 54.333. You know that what will be the empty weight of the can. This is 38.238, 36.188, 37.414 and 37.475. Then you determine what will be the moisture content. You know what will be the dry weight of the soil, you know the empty weight of the can, you know the weight of the can. So, you can deduct and can determine that what should be the moisture content of the soil. For this can number 7, the moisture content 6.990. For can number 74, the moisture content is 4774. Can number 76, moisture content 2.965, and can number 131, moisture content is 5.598. Then you can calculate what will be the dry weight. So, dry weight is 9.582, 9.683, 8.396, 16.858, and you know the moisture content, you know the dry weight, then you can calculate the what should be the moisture content in terms of the percentage. So, this is 72.95 percentage, this is 48.99%, this is 35.31%, and this is 33.21%. So, you know that what should be the moisture content. Okay, dry weight you know the moisture content. So, if you know this moisture content, then you can draw also this flow chart. So, this is the flow chart showing here, this is the flow chart. This is for the liquid limit determination. So, this is the number of the blow, this is N, and this is moisture content in terms of the percentage. So, you know that how many number of the blow you have given. So, it is known in between 10 to I say that 40 number of blow, and then you have determined corresponding moisture content. So, you know that corresponding moisture content what it should be. So, you know this moisture content. So, for a particular number of the blow, let us say this 25, and then you can determine the moisture content or the liquid limit. So, for a particular number of blow 25, you can determine what will be the liquid limit of the soil. So, here liquid limit of the soil is 52%. So, from the flow chart you can determine that what will be the liquid limit of the soil sample. Here liquid limit of the soil sample is 52%. So, that you can determine from this flow chart. So, next we can determine the plastic limit of the soil. So, take about 25 grams of the soil passing through the sieve of the size 425 micron and place it on a glass plate and mix it thoroughly with the distilled water until it is a plastic enough to be rolled. Next, roll the soil between the hand and the glass plate so as to form a thread of about 3 millimeter diameter. Now, knead the soil together and roll again until a 3 millimeter diameter thread show sign of crumbling. Take some of the crumbling material obtained earlier or in step 3 of for the determination of moisture content, and this define the plastic limit. Then you repeat the step 2 and the 4 3 times. So, has to obtain the average plastic limit. So, you can determine the plastic limit. I am showing here, this is the glass plate and this is the soil sample, and then you roll it, the soil, onto this glass plate until it make about approximately 3 millimeter diameter, and then the soil is almost going to crumble, and then you take the soil sample in that zone, and then you go for determination of the moisture content. So, it will be like a soil thread. So, here some specimen calculation is given. This is first can number 129 and 3. The weight of the wet soil of the can is 40.56. Then dry weight of the soil of the can after keeping it on the oven dry, that is 39.653. Empty weight of the can in gram 36.994, and moisture content is 0.907, and dye weight is 2.659, and moisture content then you can determine 34.11. Similarly, you take another can, another soil sample, and then you calculate what will be the weight of the soil and the can, dye weight of the soil and can, then empty weight of the can, moisture content lost, and then the dye weight, and then the moisture content you can determine. Then you take the average of this value, then you can calculate the what will be the average moisture content. Here it is 34.85%. So, this way you can calculate that what should be the moisture content of the soil. So, you can determine that what should be the plastic limit of the soil. Now, I will talk about the shrinkage limit. Take 45 to 50 millimeter diameter pretty dish and apply a thin coating of grease to inside of the dish and take it empty weight. Mix some more water in the soil placed in the porcelain dish and make it slightly flowing. Place a thin paste in the pretty dish and simultaneously tapping it, so that it fills completely the pretty dish and all the air pocket are removed. Wet the dish with the soil paste inside. Next, to avoid the development of crack during this process of drying, first keep the petri dish on the oven top for 24 hours and take only the dry weight of the soil pat. Next, determine the volume of the pat, mercury displace method or wax coating method. Determine the value of the petri dish by filling it with the mercury. Enter the observation in the record sheet and compute the shrinkage limit. Here you can see that this is the soil, this is the water, this is in first stage in the saturated condition, and then second this is the soil pat water, this is soil part at the shrinkage limit, and then after that you keep it into the oven for 24 hours, and then all the air void etc. will be removed, and we can take the what should be the dry soil pat. Now, here I have shown that this is the soil, that is a petri dish, okay, and then petri dish with soil paste inside. This is the soil paste inside the petri dish, and then you can keep this petri dish in the oven drying, and if you keep it in the oven drying, you can see that size of the sample also reduce. That means, this is the oven drying soil pat. Then this oven drying soil pat you have to place in the mercury displacement method for the determination of the volume of the soil pat, and then you determine the what will be the volume of the petri disk. So, I can now show you that how the specimen calculation can be done. Let us say that weight of the empty disk. How to calculate the specimen calculation? I am showing the specimen calculation of shrinkage limit. Okay. First of all, you have to take that what should be the weight of the empty disk. Let us say weight of empty disk. Okay. Weight of empty disk, let us say m1. This is in gram. Now, you can take that what will be the volume of the dishes. So, you can calculate the volume of dish, that is let us say V1, okay. This is V1, that is in cc. Now, weight of the dish plus wet soil is equal to m2 gram. Now, weight of dish plus dry soil, that is pat, is equal to m3, this is gram. Then you can determine that what should be the weight of wet soil is equal to, you can calculate what will be the weight of the wet soil. Okay. So, knowing this data, you can calculate that what should be the wet soil. Now, you can also calculate that what should be the weight of dry soil also you can calculate. Okay. You can calculate the volume of dry soil pat, that is V2, that is Cc. Then you can calculate the shrinkage limit. You can calculate the shrinkage limit in terms of the percentage. Okay. So, the equation for the shrinkage limit is equal to M2 minus M3 minus V1 minus V2 into rho W, this divided by M3 minus M1, this into 100. So, here from the data sheet we can say that here M2 value, M2 is equal to 54.918, this is gram. And M3 is equal to 39.119 gram. V1 is equal to 26 cc and V2 is equal to 16 cc and rho W is equal to 1 gram per cc. So, you know M2, M3, V1, V2, rho W, and this also M3 minus also M1, and here M1 is equal to 13.338 gram. Okay. Now, you substitute this value in this equation and you can determine the shrinkage limit. So, what we can write here, that shrinkage limit, if it is denoted by SL, SL will give M2 minus M3, that means 54.918, and let us see that you can take another separate sheet. Let us say shrinkage limit is defined by SL is M2 minus M3. That means this is M2 minus M2. M2 is 54.918 minus 39.119. So, you can write 54.918 minus M3 is 39.119, 39.119. This minus V1, V1 is 26, V1 is 26 minus this is V2, V2 is equal to 16. So, V2 is equal to 16 and rho W is equal to 1. This divided by M3 minus M1, M3 minus M1. M3 means this is M3 minus M1 is 13.338, M3 is 39.119, M3 is 39.119. So, you can write 39.119 minus M1 is 13.338. This is 13.338. So, you can determine this into 100. So, then you can calculate that what will be the shrinkage limit. So, this comes about 22.73%. So, in this way you can calculate that what would be the shrinkage limit of the soil. So, you can calculate the shrinkage limit. Okay. So, you know that how you can calculate the liquid limit, plastic limit, and as well as the shrinkage limit, and these are the parameters are very important for the soil testing. These are the very basic properties of the soil. Thank you.